Day 2, we are going to go over graphing inequalities, simple ones. That's the first thing we're going to do. And then we're going to do a video on graphing compound inequalities, okay? These are the steps you're going to need for both. So go ahead and get these. If you're at home, make sure that you're writing these notes down in your 3-ring binder and writing down all the examples because you will need that to complete the assignment. All right, are we good there? Okay, so what I want to do is, I want to do some examples of basic graphing of inequalities. Okay, and we're only going to do 2 examples of this. All right, so the first thing you need to know when you are graphing an inequality, all right, is you have to decide based on the inequality sign, you have to decide whether or not you're going to put an open circle or a closed circle on your number line. So the way you decide is if your sign is either a greater than or a less than with no line underneath it, you're going to use an open circle. If you have the greater than or equal to, or less than or equal to, it's going to be a closed circle where you're going to fill in. So your inequality sign is what determines whether or not it's going to be an open circle or a closed circle. So with that in mind, and looking at our inequality sign right here, it is a less than, which means on the number line, right on top of the number 2, we are going to put an open circle. Okay, so right on top of the number 2, we put an open circle. And the reason it's open is because our answer is all r's less than 2, but it doesn't include 2. So that open circle kind of works, the memory trick for remembering open or close, is that open circle works as like a protection bubble, and it protects you from touching number 2. Because 2 is not included. It's all r's less than 2, which means everything in the negative realm, 0, 1, all the way up to, but not including 2. Okay? So when we shade it, right, the next step in your steps that you just wrote down was to solve it, which this one was already solved. It was just r is less than 2. And then it was to decide open or closed on your circle. We decided open because of our inequality sign. And now we need to shade either left or right. Well, it's all of the r's less than 2. So looking at your number line, these are the r's, or the numbers that are less than 2. So that's the side you would shade. And if you want to, you don't have to. You can make it a thicker line. Okay, but it's just shading either the left or the right. And in this case, because the r's are less than 2, we shade the side that's less than 2. Okay? Now, if you look at number 2, our first step was to solve. And is number 2 considered solved? What needs to come off of there? The negative. Right. We can't have that negative on the B. So, we need to divide by a -1 and divide by a -1 because we got to get that negative off there. But when we divide by a negative, we have to remember to flip our sign. And so over here, we get B. And now the sign is flipped, so it's greater than or equal to 5 divided by -1 is -5. So now we're ready to graph this. And to graph it, we're going to put a circle on -5, and we have to decide if it's going to be open or closed. And in this case, it's going to be what? Closed, because it's the greater than or equal to, which means it includes -5. So right on top of -5, we're going to put a closed circle. And then we're going to shade, and we're going to read it, always read the variable first. So in this case, we're going to read it left to right. It's all the B's, and we're going to do greater than because the bigger part of the equals or of the inequality is facing the B's. That means you're going to shade the bigger B's. So all B's greater than -5. Well, if you look at your number line, what numbers are greater than -5? And it's everything on this side, going on forever and ever and ever and ever to the right. And if you ever want to test whether or not you shaded the right side, just pick a number on your number line that you just shaded, like say number 1, right? You shaded 1 as part of your solution set. Well, if you plug 1 in for B, is 1 greater than or equal to -5? Yes, it is. It checks out, so you shaded the right side. Okay, if you pick 1 over here on the unshaded part and you try to plug it in, like say -7, -7 is not greater than -5 because it's down deeper on the number line. Okay? So that's basic shading. That's basic graphing of just simple inequalities. You get them solved to the variables by itself, and then you decide open or closed, and then you shade left or right. Okay? Any questions on that part? All right, I'm going to do a little bit of introduction on the compound inequalities, and then I'm going to stop the recording and start it again so that I've got 2 shorter videos so that I can upload the 2 shorter videos. So a couple of things I want you to know about compound inequalities. Okay? Get this smaller so I can write with it better. There we go. All right, so with compound inequalities, okay, you're going to have 2 different kinds, and this is important because you work them different. You're going to have ands, and you're going to have ors. Okay, and ors. And you work both of them differently, and you answer both of them differently. So it's important to be able to recognize if you're working with an and or an or. Number 3 is an example of an and. And it's an and because that V in the middle goes with both sides. It goes with the left and with the right. Okay? The or, well, it's pretty straightforward why it's an or. There's literally the word or in it. So it's kind of hard to get the 2 confused, but you do need to recognize that there are and problems and there are or problems. Okay? And you work them differently. With an and problem, the only solution area is what makes both the left and the right true. And on ors, the solution area is whatever makes one or the other one true. And I'll show you kind of what that looks like here in a second with some examples. So let's look at number 3. And number 3, I've already told you, is an example of an and problem. And with and problems, I'm going to erase this here in a second, so I'm just going to put this on here just for a second to show you. With and problems, your V in the middle, or whatever variable it is, it doesn't matter. Your variable in the middle is always going to stay in the middle. And you're going to have, and I'm going to put this on here and then I'll erase it. You're going to have what in your head I want you to think of as columns. And in the middle column, you've got your variable. And on both outside columns, you have numbers. When you get to the bottom, you need to make sure that you still have 3 columns. Okay? The way my algebra teacher when I was in college said it, and it was just kind of cute and it stuck with me, is if you leave on vacation with 3 kids, when you get home from vacation, make sure you have 3 kids. Because the knee-jerk reaction, you guys have been, it's been drilled into your heads to solve, solve, solve. And what that means is to get the variable by itself on one side and all the numbers on the other, right? So you've got variable on one side and you've got some number on the other. And that's what we're used to seeing when we say solve. But if you look at this, you started out with 3 kids, and then right down here, how many do you have? You only have 2. Okay, you lost a kid on vacation, probably sitting in a gas station in Arizona, hoping you're going to notice they're gone, right? I promise you I've never lost a child on vacation. But so the other rule about vacations is when you stop for candy or drinks or whatever, if you get it for 1 kid, you get it for all 3. You've got to stick to that rule when it comes to compound inequalities. When you do it for 1, you do it for all 3, and when you get to the end of the problem, double check you haven't lost a kid. Okay, now let's look what it looks like actually in math terms, not vacations and losing children. Okay, so we're going to rewrite our problem down here. And I'm going to put this in my lap, see if it's not a little bit easier. Okay, so we've got our problem, which is 4 is less than or equal to 4v, which is less than or equal to 12. So we've got 3 columns. In the end, we need to make sure we end up with 3 columns. And we're going to get the v by itself in the middle. And whatever we do to that v in the middle, we're going to do to everybody. So we go back to what we know about solving variables and getting variables by themselves, which is how's it attached and how do we break it loose. The 4 is attached with multiplication, so we are going to divide a 4 off of it. But whatever we do to the middle, we got to do to the left and the right. Okay, all three have to get the exact same treatment. And when we do that, our v in the middle is now by itself, which is what we wanted. Did we divide by a negative? No. So our signs are still going to face the exact same direction. And then we reduce each side. So 4 divided by 4 is 1, and 12 divided by 4 is 3. Now we've solved it. That was step 1. Step 2 is to decide circles and then shade. Now we're going to do this in 2 separate steps, and here's why. This side right here is one inequality that we are going to graph separate. Okay, the v goes with both sides. So when we look at the first one, you got to read the v first, so you got to read it backwards, but it's v's greater than or equal to 1. So that tells us we're going to put our circle on 1, and are we going to do closed or open? Closed. Good. So a closed circle, and we get that because it's greater than or equal to. And then we read it, all v's, and since the wider part is facing the v, that means we're going to shade the bigger v's, right? So all v's greater than 1, which is this side of the equation. That's half of our AND problem graphed. Now we need to take that v in the middle, and we need to lump it with the other side, or that 3. So now we're going to decide open or closed on the 3. Closed. All right. And we're going to read it reading the v first, and since the small part is facing the v, we're going to shade the v's that are smaller than the 3. And that means we're going to shade everything smaller than the 3 on the green side. Now this is the important thing to remember with ANDs, okay? And this is a rule. I'm going to write it over here, and I want you to put this in your notes. For AND only. This is a rule for AND only, okay? Your last step is to shade the overlap. And the reason is because with an AND, your only answer or your only solution set is where it makes the pink and the green true. So the only part that is your answer is this section right here, where the pink and the green overlap. Okay, so shading the overlap is the last step in the AND problems. Because the pink part only makes the pink side true, and the V part, or the green part, only makes the green side true. But the part where there's pink and green overlap is the only section on the number line that makes both the left side and the right side true. Okay? So that's ANDs. Now let's look at ORs. ORs are different. Okay? ORs, you work them totally separate, you graph them totally separate, and then your answer stays separate. So what's that look like? Well, first let's do the left side. So we have 5x plus 1 is greater than or equal to 26. We are going to work this completely separate all by itself as if it was the only equation or inequality here. So we do it like we normally would, which is we got to get that x by itself. So we're going to subtract 1 and subtract 1, which gives us 5x is greater than or equal to 25. We are going to divide by 5 and divide by 5. Now we divided by a positive, so our sign doesn't change. And we're left with x is greater than or equal to 5. And we are going to graph this all by itself, just like we did the first couple of very simple ones. Okay, we're going to graph this. We're going to put an open or a closed circle on 5. Closed. It's going to be closed because it's going to include 5, because its x's are greater than or equal to 5. So on the 5, we're going to put a closed circle. And then reading the variable first, it's all x's. The bigger part is facing the x, so it's all x's bigger than or greater than 5. Well, these are the x's that are greater than 5 on the number line, because 10 is definitely greater than 5 on a number line. Okay? Now, completely separate, we're going to work the other side, which is 6x plus 9 is less than negative 9. Now we work this all by itself. So we're going to subtract 9 and subtract 9. And that gives us 6x is less than negative 18. And we're going to get that 6 off of there, so we're going to divide. Because it's attached with multiplication, we're going to get it off there with division. And that leaves 6 is less than. Now we divided by a positive, so our sign doesn't flip. And negative 18 divided by positive 6 is negative 3. And now we graph this one completely by itself. So we go to the negative 3, and are we going to put an open or a closed circle? Open. So over the negative 3, we put an open circle. And then it's all x's less than negative 3. And these are the x's less than negative 3. And with an or, you're done. Because the solution to this compound inequality, and compound just means there's two different problems. The solution to the compound inequality is either the green or the pink. And so you leave it just like this. And that's solved. Okay? Alright, I'm going to stop the video real quick, save it, and then I'm going to restart a second video so that I can upload two smaller videos rather than one large one. So give me just 1 second.